Hi everyone, and welcome to the first episode of our series on functions. See, I think functions are a lot of fun. For me, it's one of the favorite sections in the IGCSE course because there's a lot of, I don't know, I love it. It's like beautiful math, everything comes together. But it's a very wide, let's say, field of study. So you need to understand what functions are when you draw, obviously, straight lines, parabolas, exponential graphs, and even inequalities and everything. So this is pretty much the basic foundation. So I'm going to start off with really simple, and then we'll obviously continue with the course to just go like into more depth and detail. So before you start this, you should obviously know what substitution is. Substitution being if I had 3x plus 2 equals y or something, and if I told you, oh, x is equal to 3, then, okay, so then substitution would mean I put a 3 in there, and then that would give me y, so 3 times 3 is 9 plus 2 is y, so y would be 11. So kind of substitution, that's very important for you to know and understand, and obviously using variables, etc. So we're going to start very basic. Functions are, there's a lot of different types of functions, but we're going to start off with straight lines. So what do I mean with straight lines? So if I have an x and a y axis like this, the Cartesian plane, it's possible for me, you've seen people draw graphs. So we're going to look at how to draw these straight line graphs and what does it mean. So a straight line actually has a expression attached to it that kind of tells you where that line is. So let's just take a look, and then we'll see how it goes. So we're going to start off very simple. You should have done like spiders by now. If you haven't done that, let's say I do something like y is equal to x plus 1. This is a very simple expression. It's a straight line. We'll look at the standard form a bit later, but I'll just mention it now. Whenever we look at straight lines, we have a normal, let's say the standard form would be y is equal to mx plus c. Sometimes this c is also called a b, but this is kind of the standard form. Y on this side, m is just a number before the x. So in this case, if I looked at this, then there's a 1. This m would be a 1, and a positive 1. And then plus c, we'll look at that as well. C would be, obviously in this case, it's a 1. But this is the standard form we usually have it in. This is not standard form. For example, if I had 2y is 1 plus x, or y is x over 2 plus 2x, something like that would not be standard form. So standard form has the y alone on the one side, and obviously the x on the other side, and adding something else. Okay, so really basic. We're going to give some input values, and this is where the substitution comes in. So let's say input, and this I can choose my input. Sometimes, let's say, what would the question be? The question would be, hey, draw this function, y is equal to x plus 1. Draw this function. And there's there's a couple of ways of doing this. We're going to start off really simple with this kind of a spider diagram. It's also very normal to do a table method. They're pretty much the same. But the input value, that's what I'm going to choose my own input value. So I'm going to choose 1, because my one-time table is great, and 0 and negative 1. Why did I choose 1, 0, negative 1? They're just easy to work with for me. If you wanted to use 10, 100, and 1,000, that would work, and you'll get output values, but you'll see once you want to draw the graph, then suddenly, if I had a small graph paper like this, if I used very big input values, if I were to plot these points, and we'll see where the plotting comes in now, then it would be kind of very far away from the center. So when I choose 1, 0, negative 1, I try to get points close to the origin, so that when I have a small graph, I can still plot the points. Okay, but let's just take a look at this. So for this input of 1, and this input would kind of be my x values. We'll see later there's different ways of writing this. Again, I'll mention it now that you don't get a fright a bit later, but this is another way we can write this. I don't want to really go into this now, we can do that later, but I just want to show you that the function of x is x plus 1, is y is x plus 1. So don't worry too much about this. If it looks very weird to you, it's fine. I'm just showing it to you now. Later we'll go into the detail. But for now, just focus on y is equal to x plus 1. So this is my input, which is 1. So if I were to put 1 in there, then I would change this to y is equal to 1 plus 1. Obviously, I have to remember the brackets. And then y would be equal to 1 plus 1 is 2. So my output, if 1 is my input, my output would be 2. Okay, let's look at the next one. If my input was 0, let's use the different color again. Y is equal to, I put a 0 in the place of the x, plus 1. So y would be 0 plus 1, last time I checked, is 1. And I can write my 1 there. And then the next part is negative 1. So if I had to put in y is equal, my x is negative 1, I'm putting that into my function and letting it run or calculate. Negative 1 plus 1. And negative 1 plus 1 would be 0. So in this case, if I put in negative 1 here, I would have 0. So let's just take a look at what happened here. Is I have a kind of a function or a kind of expression there, and I gave it some inputs, and the function has some inputs, and now I got some outputs. And what these are, the output is actually my y. So you know, if you look at this Cartesian plane, if you were to plot anyway, like a dot somewhere, plot somewhere, a coordinate, you would have an x and a y value. So what we will do here is we can also write this in a table form where we have x and y. And in this case, our x values was 1, 0, and negative 1. And my y values, if x was 1, my y value was 2. If x was 0, then my y value was 1. And if x was negative 1, my y value would be 0. And these I can actually use as coordinates. So x is 1 and y is 2. That's a coordinate. And then x is 0 and y is 1. That is a coordinate. And x is negative 1 and y is 0. Those are coordinates. So if I had to have a look at this graph, then this would be my x value and that would be my y value. So if I wanted to plot it, I'm just going to put this over here. And then this is my x-axis. So first I'm going to look where x is 1. So x is 5, 4, 3, 2, 1. So everywhere here, from the top to the bottom, x is 1. Okay, I have a very, let's try this. It's a bit let's say thinner. So everywhere here, if I were to look at that coordinate, the x value would be 1 there, and there, and there, and there, and everywhere here, the x coordinate would be 1. And then, but I want the x coordinate to be 1 and the y coordinate to be 2. So I kind of look for the x at 1, and then for the y, I look at 2, and then where they meet, can make a little dot. Because at that coordinate is this coordinate, because the x value is 1, and the y value is 2. It's kind of easy to plot, but it's also easy to get them wrong, because sometimes you get confused and you're wondering where the x is 1 and where the y is 1. But it just comes with practice. So common mistake here would be to think of this as a coordinate. But if I look at that coordinate, then x is 2 and y is 1. So if I had to write that coordinate would be 2 because x is 2 and y is 1. So it's not the same, they're kind of switched. Okay, but anyway, so let's just continue with these coordinates we have. The next one here we have x is 0. So if I look here, x is 5, 4, 3, 2, 4, 0. So everywhere here on the y-axis, x would be 0. And then my y value would be 1. So y is 0, 1 there. So this would be my second coordinate, and the third coordinate, x would be -1. So if I look here and I follow, that's -1 right there. So it should be somewhere here. And then the y value is 0, and y value is 0 everywhere on the x-axis. Now this is a very, very important tip, and it's something that you have to understand this. If you don't understand it, then write in the comments or something that I make a video on this, but it is, for me, it's kind of basic, and it's something that you should understand is everywhere on the y-axis, everywhere on this line, infinity up and infinity down, everywhere on the y-axis, the x value would be 0. So if I look at that point, x is 0, y is 1. If I look at that point, x is 0, y is 3. If I look at that point, x is 0, y is 5. If I look down here, x is 0, y is -4. So we have this common thing that everywhere on the y-axis, the x value or the x coordinate would be 0. And then the same thing if we look at the x coordinate, well, the x-axis, everywhere on the x-axis, the y coordinate is 0. So if I look at this here, then y, well, x is 5 and y is 0. There, x is 2, but y is still 0. Okay, that's 0, 0, so both are 0. And if I look at something like this, then x would be -3, but y would still be 0. So everywhere on the x-axis, the y coordinate is 0. Okay. Oh, actually want to draw a line. So if I look at those 3 points, I can actually draw a line that connects them all. I just want to get that nice and straight here. And we can draw a line, and it would go on both sides. And what's special about this line is now what we call a function. More specifically, it's a straight line function or a linear function, meaning it's straight. Why does it matter if it's straight? Because we get other functions that are not straight. They might look like this, or they might look like that. So something special about this function, a linear function, is a straight line. Now I know this video has a lot of information right now. I'm going to end it off now just by saying the last thing. And then in the next video, we'll look at some more examples when we draw them. So everywhere on this line, this rule, this function would be true. So if I looked at, let's say I took that coordinate over there, and I wrote down the, let's say, the coordinates, the x value here is 3, and the y value there is 4. So if I look at something like 3, 4, for example, let's say 3, 4. This is my x value and this is my y value. If I drew this line correctly, and if I'm telling the truth, then if I were to put x, my input here as 3, let's say I put this 3, then, seems like I kind of rubbed out a bit here, but then my output here should be 4, if I'm correct. So let's just test that. If I took y, input is 3 plus 1, I forgot the equal sign. Y is equal to 3 plus 1, and that would be 4. So everywhere on this line, this rule is true. If I were to put x value of -4 in, then my y value would be -3. And everywhere this rule applies. So in the next video, we're going to look a bit like at another example and just look a bit in detail on like what it means for us moving forward.